Welcome to the fifth and final type of reaction, combustion reactions. They're the easiest to predict because they all make CO2 and water, so they're very easy to predict, and you're always going to need to add oxygen as one of the reactants. The word combustion means to burn, and that means we have to have oxygen present. So a lot of times it may just give you one reactant and say combustion. That means you're going to have to add the oxygen. And of course, oxygen is one of our Brinkelhoff's diatomics, so make sure you always write it as O2. Now, they're easy to predict. Sometimes they're a little trickier to balance. We have to kind of play around with them like a puzzle. Okay? There are actually two types of combustion reactions, but we're only going to be dealing with the ones that are containing hydrocarbons. And hydrocarbons are going to be something that has hydrogen and carbon. It can also have oxygen, and in some cases we will see some with oxygen, especially with alcohols, which are OH groups, or even we're going to do some with like acetic acid, the organic acids. So let's get started. Remember, anytime you see combustion, you're always going to add the O2 right here, and then you're just going to balance it. The tips that I like to tell you, and it's actually backwards in your notes. Let's look at the next page, and that is, it says to balance the carbon first, but I want you to circle and say balance the hydrogen first. Okay, it makes it easier because sometimes if we see that we're going to have to put an odd number in front of water, we're going to bump up the hydrocarbon to a 2. Okay, and so let's just get into this. So first of all, we have C3H8, which is propane, plus oxygen, and it makes CO2 plus water. And what I always want to do with these is I want to look right here, okay? And I want to see, am I going to have to put an even or an odd number in front of my water? And the reason being is the other oxygens present in the O2 and in the CO2 have a 2 subscript. And no matter what number I put in front of a 2, it's always going to be an even number. But over here, with the water, I only have a single oxygen. And so I'm going to need to make that be even. Since I can't make the other things ever be odd, I'm going to need to make this be even. So if I check my hydrogen first, and I see that I have 8, so half of that is 4, so I'm going to need to put a 4. So I'm going to proceed as normal. Okay? Now I have 3 carbons, so I'm going to put 3 right here. And then I will add up my total oxygen count on the product side, which is 3 times 6 is 3 times 6, 3 times 2, I have 6 here, plus the 4 from water, gives me a total of 10 oxygen. So I'm going to put a 5 right here, and then I'm done balancing. So for the next one, we have actually propanol, which is basically propane. We take off one of the hydrogens and we put that OH group on there, which is going to change the way we're going to balance this. Again, going to make CO2 plus water, okay? And now I'm going to look at my count, and right now I have 8 total hydrogen. So that means I would need to put a 4, and then I have 3 here. So again, I would have 10 oxygen over here. But look what happens whenever I go back over here. Now I have a single oxygen that I am going to be odd over here. So even if I were to put that 5 right there, I would now have 11 oxygen, which would not be balanced. So this is not going to be able to work. So I'm going to say, let's scratch that out, and we're going to say that's not going to work, that's not going to work, that's not going to work. Okay? So I'm going to rewrite it down here just to help y'all, because sometimes you do have to play around with it. That's why using pencil during this time is often more beneficial than pen, so you can erase. So now when I see that I'm going to do that, I'm going to automatically try bumping that up to 2 and then go from there. So now I would need 8 times 2, 16 hydrogen, so I'm going to put an 8 there, and then I need 6 total carbons, so I'm going to put a 6 there. And then when I look at that, I have 6 times 2 is 12, plus 8 is 20 oxygen. So I go back over here, and I'm accounting for these 2 here, so that means I would need to make this be 18, and I would do that just by putting a 9. Okay? So those are the examples of combustion reactions. On this next slide, we're looking at your common hydrocarbons, just so you can kind of be aware. So when you see these things, normally when we do a hydrocarbon, I'm going to give you what the formula is, but I do want you to be aware of this, specifically methane. You should memorize for sure methane. It's good to memorize all of them, just so when I say propane, you know that means pro means C3, the eth part, it means C2. When you go on to AP Chem, you'll learn those base words, because if it's an alcohol, then we would say ethanol, propanol. Acetic acid would be a carboxylic acid, and so acetic is its common name, which is coming from ethane. After that, it would go to like propyloxic acid and things like that. But you won't have to know that until you go on to take AP Chem. So we're going to work a couple of examples. I am recording this lesson at home while it's icy and sleety outside, and so I don't have the notes with me. However, I could refer to Canvas and get the packet that we've been working on. So if you will pause this video, and if you don't already have your packet out, grab the Predicting Products packet that we've been working on in class and turn to the hydrocarbons, because I'm going to work a couple of those as examples since I don't have the notes with me at home. All right, let's get ready to work these examples. Okay, so I'm going to start with, I think, the first one in your packet, which was C6H6, which is something called benzene, which is a known carcinogen, meaning it causes cancer, but it's very common. It used to be used as a solvent, and people used to wash their hands with it before they knew it was a carcinogen. So thankfully, they've learned that, and people stopped doing that. So I look at this one, and first thing I check is that's a 6. That means I would need to put a 3 in front of water, which is an odd number, so it's not going to work this way. So we're going to automatically bump that to 2. Then I would need to put a 6 here for 12 total, and then I need to put a 12 there for 12 total carbon, and then I look at my total oxygen count, and I see 12 times 2 is 24, plus 6 is 30, and so then I would need to put a 15 there, and I'm done. Okay? If you look a little further down your packet, we should see acetic acid, which is HC2H3O2. Sometimes you might see acetic acid like this. That's the organic chemist way of writing it, but it would work the exact same because all your counts would be the same. It just got to be careful that you count both carbons. All right, plus oxygen, because combustion means burning, makes CO2 plus H2O. And so I'm going to look at this, and I see 4 total hydrogen. So that's an even number that I would need to put here so I can proceed. And then I have 2 carbons, so I'm going to put that there. And then I do my oxygen count. I have 2 times 2 is 4, plus the 2 from water gives me 6. So I need 6 over here. I currently have 4. So if I put a 2, now I have 2 times 2 is 4, plus the 2 from acetic acid, and I have 6. So that is now balanced. So I'm going to do 2 more, and then I think we're going to be done with this lesson. Let's do pentane, which is C5H12, plus our oxygen yields CO2 and water. So I check my oxygen. I see that it's a 12. Half of that is 6, which is an even number, so I'm going to proceed. And I'm going to see that I need to put 5 there. And now I have 5 times 2 is 10, plus 6. I have 16 oxygen that I need, so that can be balanced by putting an 8 in front of oxygen. And then let's do the next one. After pentane comes hexane, which is C6H14 plus O2 yields CO2 plus water. Check my hydrogen, and I see that half of 14 is a 7, which is an odd number, so I do not want to put that in front of water. So I'm going to just quickly bump that up to 2 to make my life easier. And then I would put a 14 here. I would put 12 carbon here for 6 times 2 carbon. That gives me 24 plus 14 gives me 38 oxygen. So in order to balance oxygen, I'm going to put a 19 here. Now when you're balancing these combustions, do not be afraid of big numbers that need to go in front of oxygen. It's very common. So don't let that alarm you. Now, you sometimes might see If you're looking for help on the internet for combustion, sometimes they will put fractions in front of the oxygen and not put a 2 in front of here. And while that is perfectly correct, we just don't do it that way in here, because for us, we like to keep them as whole numbers so that we don't get confused. And that is the end of the combustion lesson.